So in this question, we've been told that the number of patients attending a hospital trauma clinic each day was recorded over several months, and that's given rise to the data in the table below. Looking through the table, the very first thing that I notice is that the upper limit of one interval and the lower limit of the next interval do not match. There are gaps in between those limits. So for the majority of calculations that I want to do, I'm going to need to be careful to close those gaps by using bounds. We've been told that the data are represented by a histogram. The information we're given is that the bar representing the 20 to 29 group is 2 centimeters wide and 7.2 centimeters high. We're going to make a diagram to represent both the class width and the centimeter width, and to represent the frequency density and the centimeter height. We're then going to use that to calculate the dimensions of the bars representing these two other groups. So let's focus on the information we've been given. So this first bar is for the group 20 to 29. We're going to use bounds, 19.5 to 29.5. There's a frequency of 18. The class width is 10. That's the difference between these bounds. And the question told us that the drawn width, the centimeter width, was 2 centimeters. From here, we can get a scale factor, which says whatever the class width is, if we divide by 5, we find the centimeter width. We find the drawn width. Okay, frequency density is frequency divided by class width, 18 divided by 10, that gets us 1.8. And this time our scale factor to the centimeter height is to multiply by 4. For every bar in this histogram, if you calculate its frequency density, you can multiply it by 4 to find the height that you would have drawn that histogram. Now that we know those scale factors, we can move on to the rest of the question and apply those scale factors. This bar represents 30 to 34. Once again, we have to use bounds. 29.5, 34.5. That gives us a class width of 5. The drawn width I can find by applying the scale factor. The scale factor said divide by 5. The drawn width, the centimeter width, is 1 centimeter. Frequency density is the frequency, the 24, divided by the class width, 24 divided by 5. We can find the centimeter height, the drawn height, by applying our scale factor of multiplying by 4. 4.8 multiplied by 4, 19.2. These are the bits we would usually be asked to find in an exam question. Exactly like this. Find the scale factors, apply them to a different interval. Apply them to a different bar. Okay, next, 50 to 69. This time round, the bounds, once again, 49.5 to 69.5. So this is the widest class width we've had so far. It's going to be a class width of 20. We can find the drawn width by applying the same scale factor. We're dividing by 5. The drawn width, the centimeter width, is 4 centimeters. How about the frequency density? We're going to go for the frequency of 5 divided by that class width of 20. So this is quite a small frequency density. We're getting 1/4. Apply that scale factor, multiply by 4. That's how we find the drawn height. 1/4 times 4, 1 centimeter. That will be the drawn height for this bar. So once again, we use the information in the question to find the scale factors, which we can then apply to each and every one of the bars as necessary.